Today we're going over chapter 3, section 3, proving lines are parallel. Here we have corresponding angles converse theorem. So if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Guys, remember what a converse means. It's the opposite, so it's the reverse of the 3-2 theorem that we learned. So it's a converse. You guys remember the if-then statement, so it flip-flops them. Or the if-then if it makes it easier. Now, if two lines are cut by a transversal and the corresponding angles are congruent, and then the lines are parallel. What does that mean? That in this case, if angle 2 is congruent to angle 6, then lines J and K are parallel. In this, we're using the corresponding angles converse theorem, so the one that we have right now. Because we have the angles are congruent, we can say the lines are parallel. In the last lecture, we learned that if two lines are parallel, then the angles are congruent. So now we're just working them backwards. I'm going to write the reason right here. So these are some theorems. Alternate interior angles converse. Again, guys, the word converse will tell you that it's the opposite of the theorem. We flip-flop them. So if two lines are cut by a transversal and alternate interior angle are congruent, then the lines are parallel. I will draw, or try my best to draw two parallel lines in a transversal. Let's call this line P and line Q. I'm gonna give angles 1, 2, 3, 4, 5, 6, 7, and 8. So for example, if I use angle 3 and angle 6, because alternate interior angles, we can say if those three, so angle 3 is congruent to angle 6, then line P and line Q are parallel. Now, for another example, let's do the alternate exterior angle, converse. So if two lines are cut by a transversal and alternate exterior angle are congruent, then the lines are parallel. So for example, if we use, let's say, 2 and 7, we can write if angle 2 is congruent to angle 7, then the lines P and Q are parallel. Sorry, guys. This is the consecutive interior angle converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Again, to explain this, I'm going to try to draw to the best of my abilities this figure. I'm going to write angle 2, angle 3, and angle 4. I'm only writing the interior ones as the theorem, or the converse in this case. It's only talking about interior angles. So I'm going to give them a value. I'm going to say angle 2 is 110 degrees. I'm going to say angle 3 is 70 degrees. So what this is saying is if angle 2 and angle 3 are supplementary, then lines, let's name them M and N. Lines M is parallel to line N. I hadn't named them, but after I did, that's what it's saying. If the two angles equal to 180 after being added, then the two lines are parallel. This is a transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Again, try to explain it. I'm going to try to do as best as I can. Let's call this top one J, let's call this middle one K, and then let's call this lower one L. So what this is saying is, if line J is parallel to line K, and line K is parallel to line L, then line J is parallel to line L. Again, this is a transitive property. You guys see the middle one kind of disappears because the first one's equal to this is parallel to the second is parallel to the third, so we can say the first is parallel to the third. These are some ways to prove that two lines are parallel. Again, I'm going to draw small, same thing I've been drawing. I'm just going to name these 1, 2, 3, 4, 5, 6, 7, and 8. So, ways to prove two lines are parallel. 1, we can show that a pair of congruent angles, corresponding angles are congruent. In this case, a pair for corresponding angles with, for example, 2 and 6. So, if 2 and angle 6 are congruent, then those two lines are parallel. Show that a pair of alternate interior or exterior angles are congruent. So for a pair of interior, we're going to have, let's say, 4 and 5. So for interior, let's do green. And then for exterior, I guess let's do yellow. We can do 8 and 1. Then for the third one, show that a pair of consecutive interior angles are supplementary. We can say if angle 3 and 4 add up to 180, then that would be good. So angle 3 plus angle 5, I meant to say 5, sorry guys, is equal to 180. And lastly, we can show that both lines are parallel to a third line. So if there were a third line in this drawing, let's say down here, and those were parallel, we can say, well, one of them is parallel to the other line, and then the other one's parallel to the third, so the first one is parallel to the third one. So this is an example. They're asking us which segments are parallel lines. Now, the first thing you guys should do in order to figure this out is to find out which is the transversal. So, to put the transversal, I'm going to extend these two. You don't have to extend them if you don't want. But in extending those two lines, I realized that this middle one is a transversal. Again, the transversal is the one, let me write it down. The transversal is the side in common with all the other lines. So now, to figure this out, we can use different theorems and different converse. Because they give us only to the right of those two lines that could possibly be the parallel lines, I'm just going to go look for corresponding angles. Now, the first one I can look at is these bottom ones, 36 and 38. They're not corresponding, so I'm going to move on. 24 and 22, again, not corresponding, so I'm going to move on. I'm going to add both of these to see what happens. If I do 24 plus 36, I get 60. So the addition of this whole thing is 60. And I'm going to do 38 plus 22. And again, this whole addition is 60. Now, because they're 60, we realize they're talking about this big angle, not the smaller one. So we can say that line AC and line BE are parallel. So I'm going to write that in. AC is parallel to BE. E. And I also want to write in the theorem that we use. So corresponding angles converse theorem. Now, why did I use that one? Because both corresponding angles are congruent. Then lines are parallel. So they want us to find what x value makes AB parallel with CD. Now, we're going to use corresponding angles because we really don't have much else to go off on. I'm going to mark the transversal first. So again, this is a transversal. So we figure out where that transversal was, and we're going to use corresponding angles to figure this out. Since they give us that this is 90 degrees, we want to make sure this whole angle equals 90 degrees. So if I do 90 minus 40, I'm going to get 50. So that's the value that I want x to be in order to make the lines parallel. We're going to be using, I'm going to write for the congruence, if corresponding angles are congruent, then lines are parallel. So this will be it for today, guys. We will continue the notes on Monday. Find the value of x and y that makes J and K parallel and L and T parallel. So guys, let's take it into two different steps. You can just do one at a time. So I'm going to do it in colors to make it easier. If you do it one at a time, it'd be easier to figure out. Okay, so let's do it based on the J and K. So this is J and this is line K. If we want to say that they're parallel, we're going to have to use something to make it work. Now, the transversal is going to be either L or T. I'm going to say that it's L because I realized that we have 60 and 3x as corresponding angles. So we can say that 3x is equal to 60. So we're going to divide by 3 on both sides, which is going to give us x is equal to 20. Now, the reason I'm solving for x is because 20 times 3 is going to give us 60, which that would prove that the angles are parallel. So honestly, you can use it. You can just make it like convenient for what you're trying to solve. I'm going to write down the reason. Those are corresponding angles. Now for the next one, we're going to do it in blue. So they're looking for lines L and T to be parallel. And the only actual numbers that we have is that 60 and then that 2y. So we're going to use the 60 and the 2y to figure it out. Now, I want you guys to realize these are alternate interior angles. They're alternate interior angles. So because they're alternate interior angles, they equal to each other. So I'm just going to write 2y is equal to 60. Again, divide both sides by 2. And I get that y is equal to 30. Now, because y is equal to 30, 30 times 2 is 60. Those are congruent. So we can say that those are alternate interior angles. And since alternate interior angles are congruent, those two lines are parallel. So guys, this is an example for snake patterns. So how can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? If you guys notice, they draw like an angle right here and an angle right here. Those are alternate interior angles. So if the alternate interior angles are congruent, then the lines could be parallel. The reason I'm saying could and not will is because we don't actually know if they're parallel or not based on that drawing. But in the case that they are, they will be, but I'm just going to write they could because they have to be first congruent.